Okay. All right. So yesterday we were talking about, first thing we were talking about was, wait, let me just make sure my mic is working. Okay. So we started talking about rules for differentiation, right? We started with the most basic rule, which we're going to continue to use today, and you're going to continue to use probably anytime you're finding a derivative, the power rule. Okay, the power rule says the old power moves to the front and gets multiplied, and then we subtract one from the old power that was there. Okay, so instead of 5x x to the fifth power, 5 moves into the front and it goes down a power. Okay, and then if it doesn't have a power, we can turn it into a power, whether it's a fraction power or a negative power, that kind of thing. Okay, so that's what we talked about yesterday. And then any constant is going to have a derivative of 0. Okay, and that's an offshoot. And then we talked about, so mainly what we looked at was the power rule. Okay, mainly because we did the power rule for these guys, we did the power rule a couple times, right? For A, we did it 1, 2, 3, 4 times. For B, we did it 3 times, right? It's just pretty much an offshoot of the power rule. Okay, and then we did one of our questions where we're finding an equation of a tangent line, right? We've done questions like that before, but less work, right? This question took 2 pages before when we did the definition, but now it's only, takes up not as much space. Okay. And then we ended with that problem. So we're going to look at this type of problem here, but a different way. Okay, you can multiply using FOIL, right? We said FOIL works and you can do it using that. That works. But there's also another method, which is called the product rule. The product rule. Okay, so what does the product rule say? The product rule says if I'm finding the derivatives of two separate functions, okay, I can use this method here. Okay, so u means original u, whatever it was to begin, you put it in the front, times the derivative of v, okay, plus the opposite, the original v times the derivative of u. Combine like terms and you're done. Okay, now be careful, this doesn't mean this. Like for this problem, some people think this is like if I have f of x equals 5x squared, some people think that's a division. Sometimes people think that's a product. This is not a product because 5 is just a coefficient, right? It's not. If I put an x there, then for sure, right? Then you would have 1, 2. But just be careful when you're using this that it's 2 separate functions. Okay. Okay, so let's look at the first one. Okay, so this guy here, we have a binomial here, and I have a binomial here. Okay, we can do FOIL just like we did yesterday. You can do FOIL, that works. Nothing wrong with that. But since we're doing the product rule, let's look at it at a product rule. Okay, so the first thing is I see I have a power or a root here. I see the second term in the first binomial has a root. Anytime you're going to use any type of differentiation, it doesn't matter which rule, you don't want a root, you want a power. Okay, so I'm going to rewrite it. I'm going to rewrite the problem. 3 is okay, but instead of 2 times the square root of x, how would I write that? But no root and a power. How would I write that? How could I write 2 times the square root of x with no root? Yeah, you right. There you go. Exactly. 2 x to the 1/2 power. Says the exact same thing. Okay. And then this part is okay. So again, you could use FOIL. FOIL works. That works for this problem. But let's try a different method. So the product rule says, so this is going to be our, let me shade it so we know which one's which. This one is going to be our U. And this one right here is going to be our V. Okay. So the product rule says U by itself. Okay. So I'm going to write U, Y prime, U by itself. Okay. Times the derivative of V, the derivative of the next guy, the one in the magenta color. Well, the derivative of this guy, what is the derivative of the magenta color going to be? What's the derivative of 5x cubed? 15x squared, good. And then what's the derivative of -7? 0. So we don't need to write that. Plus. Okay, now the opposite. Now let's write V. So V was 5x cubed minus 7, right? Now we have to do the derivative of the first one, U. Okay. Well, let's look at U. The first term is a constant. So 3, the derivative of 3 is just going to be 0. Okay. The derivative of, now we got to do the derivative of this part here. So we're going to move the 1/2 to the front, right? The 1/2 is going to move to the front and get multiplied times the 2. So 1/2 times the 2 that's already there. And then what power of x is going to be there now? Or how do I figure it out? Exactly. Subtract it -1. So you write it out here since this is our notes. So it was 1/2 before, right? So I'm going to subtract it -1 whole. Well, if I'm subtracting fractions, it's easier probably to write it as 2/2. Okay. All righty. So I'm going to simplify that. Okay. I'm going to simplify that a little bit. So we have plus, and then over here, I have 5x cubed minus 7. And then over here, I can simplify it, right? 2 and 1/2 will cancel out. So that'll just make x. And then 1 minus 1/2, or 1/2 minus 1 whole is -1/2. But again, that's never going to be an answer. If this is a multiple choice question, you're never going to see that answer because of the -1/2. So let me clean it up. So instead of -1/2, I could put 1 over the square root of x, because that's really what it is, 1 over the square root of x. And then since they started with roots over here, I'm going to change this back to a root over here. Okay. Now here's the thing. If this was a free response question, that answer right there would get 100%. I would give you 4 out of 4, 3 out of 3, whatever it was. If you did this if you gave me this answer here, I would give you full credit. I wouldn't give you full credit for the one above because that one needs to be reduced. I'd give you almost full credit, but I wouldn't give you total full credit for here. This one I would. Here's the problem though. On multiple choice questions, it might be reduced even further. It might be reduced even further. Like you might get to there and none of the answers match. So how can we reduce this even further? how can we reduce this to go even further? I don't want to say reduce, but Flores. I can't today. I'm sorry, ma'am. I'm sorry. Okay. All right. Bye. So what's one thing we could do to simplify it? Just in case, because I've seen this before. People taking group tests, quizzes, tests, and they do the problem. They're like, Mr. Flores, I did the problem, but my answer doesn't match. I can't help them because it's a test. So how could we simplify this? How could we simplify it? What could we do to simplify this or reduce it or anything like that? Mm-hmm. That would be the first step. Yeah. I'm not going to actually do it, but I'm just going to show you the steps. So I would distribute that and distribute this, right? I can do that. And then I can distribute that and distribute this, right? I could do that. And then when you do that, you're going to get 15 times 3, which is 45 x squared. And then 15 times 2 is 30. And then how do I combine, or how do I multiply x squared times x to the 1/2? What do I do there? What do I do to the exponents? If I have x to the 1/2 times x squared, how do I do that? Add the exponents. Yeah, don't multiply, add the exponents. So you'd get 2.5, right? Equals x to the 2.5, which is 5/2. Right? Over here, you would do the same. Multiply, multiply, and then combine any like terms. If there are any like terms, combine them, and then you're done. That's as far as you can go there. Okay. Again, I don't know, because sometimes they like that answer. Sometimes they want you to simplify it further. On a free response question, this answer is completely fine. Okay, so I just caution you on both. Know how to reduce it. Know how to, okay, I can do distributive property. Okay, then I can combine like terms, and then that's it. Okay. So that if you need to, you can. Okay. So let me put that on the notes. If asked to simplify. If you're asked to simplify. Okay, again, that's not a calculus thing. To simplify it is not calculus. To simplify it is algebra. But if it doesn't match A, B, C, or D, you can't put an answer, right? I can't put my own answer. I have to pick one of theirs. Okay. Okay, so try B. Try B on your own. Use the, don't FOIL, use the product rule. Use the product rule to simplify B, or to find the derivative, I should say, of B. Y prime. Okay. So that is, again, calculus is done now. So in my mind, this is a good answer. Again, on a free response question, this I would give you full credit for, absolutely, because I'm not so concerned with the algebra. I'm more concerned is, did you find the derivative? That is the derivative. Now, again, on a multiple choice question, you could distribute this guy, right? And then you could FOIL this guy. First, right? You could do that and simplify it that way. Okay. If you're asked to, that's the way I would do it. Okay. But for right now, I'm good there. Okay. But they might, like I said, they might have you do that further. But we're not going to go that step because this is a calculus class. It's not an algebra class. Right. But like I said, if they ask you on a multiple choice, just be prepared to do that. Okay. Okay. So the other rule, obviously, if there's a product rule, there has to be a quotient rule. Quotient's just the opposite of product. Product is multiplication, quotient is division. So if we have a division problem, something divided by something, we can always use the quotient rule. Okay. So find the derivative of each. Okay. So this one has a different, okay. So this one has a different one. So we start with the function on top is u, the function on bottom is v. So this time we start with v times the derivative of u minus u times the derivative of v all over v to the second power, v squared. Okay. So it's a little bit different. It's got more components to it since it's division. So one thing I forgot to talk about, let's go back up here. Let's say it's a test or a quiz, and I know I'm supposed to do the original times the derivative of the other, and the original times the derivative of the other, but I forget which order. I'm like, which order? Does order matter on this guy here? Order that I multiply and add. Like, what if I switch these? What if I take this guy here and switch them here? Like switch both of these guys in spots like that and add them together. Well, is that okay? Yes, that's okay, right? That's okay, because multiplication and addition can be flipped like that, right? Is that okay with the division? With the quotient rule? Is that okay with the quotient rule? Can I do this? Can I take this guy here and this guy here and flip them and subtract them? Yeah. Yeah, right? Take two numbers. 3 minus 1, right? You get positive 2. But if I switch them, I get a totally different answer, right? So subtraction, it doesn't work. So this one, order matters. Okay. So product rule isn't that hard because it's just 1 times the derivative of the other plus 1 times the derivative of the other. This guy here, order matters. Okay. So few of my students from past years have come up with ways to memorize this. Okay. So this is their method. This is their method. See if it works. If it sticks, great. They say this. This is what they say. Low d high minus high d low over low squared. Low d high minus high d low over low squared. Low squared is probably the easiest thing, the bottom squared. That's usually where we start because it's just easy. Just square the bottom. But low d high, low d high. So what does low d high mean? Well, low means the low one first, d high, derivative of the high, minus high, d low, derivative of the low. Okay, over low squared. Okay, low d high, high d low. Start with low, low, D high, high, D low. Okay. Like I said, that's one way. If it works, great. If it doesn't work, don't worry about it. Okay. So let's do a problem like this. So let's look f prime of x. I always start with the bottom because the bottom is usually pretty simple to write out. It's just the bottom squared. Bottom squared. Whatever's on the denominator of the original is just squared. Okay. So now let's do this guy, the top. Okay, so now we're going to do low. Low was x squared plus 1. So x squared plus 1 times the derivative of the high, d high. Well, the derivative of x is just positive 1 minus. Now, when I do minus, I always do brackets here because it's minus this whole entire thing. It's minus this whole entire, I always do brackets here because I'm subtracting that whole mess of stuff there. Okay, so over here, it's high x d low, derivative of the bottom, which is just 2x, right? Now they're always going to want you to simplify this one. Okay, this one is the one they always want you to simplify. So let's simplify it a little further. I can distribute the 1, but that's not really going to do anything. So x squared plus 1 minus, and then it's not really distribution, it's just multiplying these two guys. So 2 times x squared is just 2x squared over x squared plus 1 squared. Okay, combine any like terms if you can. So I can combine this guy and this guy. So I get negative x squared plus 1 over x squared plus 1 squared. These guys look very similar. If I look at them, if we look at them here, this guy here and this guy here look very similar. Can I cancel them out? Yeah, no, I can't because of this negative sign. If this negative sign wasn't there, I could do it. I could cancel this out with one of these, but I can't. Even if I took out a negative, even if I took out a negative here. So let me take out a negative 1. It would be x squared minus 1, which doesn't really help me because now it's not the same. This is difference of squares though. This is difference of squares, right? X plus 1, x minus 1. But the only reason I would factor it is if it canceled something on the bottom, and it's not going to. Okay. So this is okay. This is okay. They're both the same. Either one. Either one is okay. All right. Try the second one. Try number 2 on your, or letter B. Do that one on your own. How many people said high D low or low D high D low in their head? No, don't lie. I know some of you guys did. It works. It sticks in your head. That's why it works. Low D high D low, right? So low D high minus high D low. Okay. They like you to simplify this. I've never seen a multiple choice question where that was the answer. Okay, I've never seen it. They always like you to simplify. Okay. So let's simplify. 10x to the fourth plus 10x and then over here I have what do I have, 15x to the fourth over x cubed plus 1 squared. So I can, since there's only one term now in the brackets, I can get rid of the brackets. So we get negative 5x to the fourth plus 10x over x cubed plus 1 squared. How do I know I'm done or if I can further go? Here's what we can do. I can see on top here. You can see on top here, I can factor out. What can I factor out on top? What do they have in common? What do those two terms have in common? A negative 5 and what else? The power of x, right? So I can see I can factor out. Do I do it? Do I actually factor it out? Here's the thing. If it will help you simplify with something on the bottom, like if you're like, ooh, if I factor that out, that's going to cancel out with something on the bottom, then do it. But if it's not, don't worry about it. Okay, so let's kind of do this mental math in our head. If I were to factor out a negative 5, what would that leave? It would leave x cubed minus 2, right? That's not going to cancel out with this guy here. Close, but it would be an x cubed minus 2 and not an x cubed plus 1. So you could factor it out. It's not wrong, but it's not needed. The only time we factor things out is if it's going to cancel out with something. Or if you don't know if it might cancel out with something, okay, then try it. There's nothing wrong with saying, oh, let's see, negative 5 x cubed minus 2. Nope, doesn't cancel out. That's fine. You can just do it like that. It's the same answer. Okay. Alrighty. Okay, so last thing, higher order derivatives. Second and higher order. So higher order derivatives are just second, third, fourth, fifth, sixth, seventh, nth derivatives. It looks a lot more complicated than it really is. So if I said, find the fourth derivative of this guy, what do you think you're going to do? What do you think the first thing is you're going to do if I wanted you to find the fourth derivative of that guy? What do you think the first thing is? Take a wild guess. I bet you're right. Not even necessarily, if you can. If there's like terms, definitely. But if I was going to find the fourth derivative, what do you think I would do first? Not the fourth term. Even easier than that. You guys are thinking way up here, even down here. No, you guys are up here. You guys are thinking way high. Find the first derivative. Yeah. You can't get to the fourth unless you're at the first, right? So find the first derivative. That's not too bad. So let's find the first derivative. Okay. So multiply it here. We get negative 40 x to the 7th plus 12x to the fifth minus 27x squared plus 32, and that's it, right? Okay, what do you think I'm going to do next? I'm not to the fourth yet. What do you think I'm going to do next? Do it again. That's the guess what that's called? The second derivative, right? That just means we have two little tick marks there. Two tick marks mean the second derivative. Okay, so we multiply and we get negative 280 x to the sixth using the power rule, 60 x to the fourth minus 54x, done. We're almost there. What do you think we're going to do next? The third derivative. All right, so let's see. What's 28 times 6? Something with an 8, carry the 4, it's negative 1680 plus 24x cubed minus 54. One more time. Eventually, the tick marks, you can see eventually they don't use tick marks anymore. They just use 4s. You can use that. That's okay. Very rarely are you going to have to find the fourth derivative. In this class, the most we usually go is second, maybe third. Okay, but they're just trying to prove a point that this is how you do it. Okay, so let's see, 1680 times 5, 34, 840, negative 840, 8,400 to the fourth plus, let's see, 240 times 3, 720, done. Okay. Now there is significance behind the derivatives. Like we're gonna, next chapter, we're gonna use second derivative quite a bit because it does tell us some things. But like I said, when we actually start using this application, usually we won't go farther than the second derivative, but they're just trying to prove a point that you can do it. Okay. Okay, so let's do the second derivative of that one. Okay, so the first derivative, low d high minus high d low. Okay, and then you simplify it. X's cancel out once I do distributive property over here. And once I multiply, I get -1 over x minus 1 quantity squared. Right? Okay. Now I got to do second derivative. So second derivative is just derivative of this guy here. Okay, so let me see. So I have x minus 1 squared. So what is that? In other words, it's x minus 1 to the fourth power. So instead of writing it double like that, I'm just going to write it to the fourth power. Okay. Low d high, which is the derivative of the top now. The derivative of the top here is what? 0. Yep, that's nice. When you get derivatives that are 0, it's nice. Why is it nice? It's going to cancel everything out. Yeah, look at this guy over here. Don't matter what this is. Anything times 0 is just 0. So that's all that stuff's going to cancel out. So the opposite, high times the derivative of the bottom here. The derivative of this bottom right here. How do I find the derivative of x minus 1 squared? What do I have to do first? I have to expand it. So let me look over here. So x minus 1 squared is the same thing as x minus 1 times x minus 1, right? So let me do FOIL first. Outer, inner, multiplication, last. So when I simplify that, I'm going to get x squared minus 2x plus 1. That's what I'm going to find the derivative of. So I got to put the derivative of this guy here, right there. So the derivative of that guy is going to be 2x minus 2. Okay. Simplify within the brackets. Simplify within the brackets first. So I'm going to do distributive property here. So be careful with your negatives. The first term, again, the first term here, gone. I'm not worried about it. It's 0. This whole thing is just 0. So it's negative. And then within the brackets, I have negative 2x plus 2. And on the bottom, I have x minus 1 to the fourth power. So be careful with your signs here because it gets a lot of negatives going around. Okay, so now I'm going to distribute that negative sign. And I get positive 2x minus 2 over x minus 1. And then what did I say was the reason why? How do I know if I'm done or if I should factor more? What did I say about 10 minutes ago about that? When we decided not, probably more than 10 minutes ago, maybe 15 minutes ago. When I decided not to factor, I'm like, yeah, I don't need to factor. I did it anyway, but I said, you know what? I don't need to. What was the reason why I didn't take out a -5 there? What was the reason why? Okay, so let's use that same reasoning. Let's use that same reasoning. Will something cancel out if I do it here? I'll give you a hint. Your head should be doing this. Yes, it will, right? They both share a 2 in common. Factor out a 2. Oh, those look the same. These two guys look like they're exactly the same. Because they are. It's multiplication, right? It's 2 times this, 2 times this. So I can cancel out. So what I can do is I can simplify that guy. Now, here's the thing. How do I simplify the bottom? Do I do this? Done. Yay. Do I do that? Can't do that. Because, let me go back. Let me see. Because what this means is this. X minus 1, X minus 1, X minus 1. Anything to the 4th power just means it's multiplied times itself 4 times, right? That's the definition of to the 4th power. So I can simplify with one of these guys, not the whole thing, just one. So now it's 2 times 1, and I'm left with X minus 1 to the 3rd power. Let me write that 3 a little clearer. Okay. So again, that last part here that we were focused on, that wasn't calculus. Okay, the calculus was done right there. I was done with the calculus there. Everything I did after that was simplifying. Was just using algebra. Okay, so like I said, the hardest part about this class isn't the calculus. It's everything else. It's all the stuff that we've done before to learn how to simplify. Do I ask yourself, like if you're here, like I'll get a lot of students here. And they're like, I'm done. Okay, I'm done. Move on to the next problem. And if it's a multiple choice question, they get 0 points. If it's a free response question, I'll give them 3 out of 4 or 2 out of 3. You know, I'll give them most of the credit because they did it. But a lot of times you'll see these on multiple choice questions, and multiple choice questions will kill you because if you put the wrong answer, there is no partial credit. Okay, so again, simplifying this is not a calculus thing. It's just an algebra thing. Okay, so just make sure if you can simplify. Okay. Okay, so the last one, we don't really have to do it. Just tell me what to do. You don't have to do it. Just tell me what the question is asking. What is this question asking? Even easier than that. Just find the derivative. Yeah, it's just a fancy way of saying find the derivative. It said find the 5th derivative, because that's what those 5s are. Find the 5th derivative, right? If this is the 4th. So how do I get from the 4th to the 5th? You find the derivative, right? That's it. You're done. Find the derivative. Okay. So yeah, that's all. You don't have to do it. You can if you want, but you don't have to do it. I just wanted to know because that notation sometimes is confusing. Okay. Alrighty. So on Monday. So I was gonna assign you something, but I'm not going to anymore because I'm gonna leave it till Monday. So Monday, because this is so important, because the last 2 days, the last 2 lessons, and we have a quiz. Remember, we have a quiz next week. Are so important. I want to give you guys a day to kind of review what we've done so far. So I'm going to push the assignment till Monday. I'm going to give you Monday. We're not going to do anything new. I'm going to give you some class time to work on the assignment I was going to give you. Okay, so I'll give you all of Monday to work on that. So if you need help, you have access to everyone in the class. You have access to me. So if you have questions, and then so yeah, so so we're probably we're going to do a quiz on Tuesday then, because we'll have that data review on Monday, and then on Tuesday we'll do a quiz. Okay, so instead, I think I said Wednesday yesterday. I think so. Tuesday, we're going to do a quiz on Tuesday. What's the quiz going to cover? It's going to cover the assignment that I give you, pretty much everything on the assignment I give you. It's going to be probably 3 questions, maybe 4. It's not going to be very long. Okay, on Tuesday. All righty. So no new assignment. I think there is an assignment due today, isn't there? There is an assignment due today. So if you haven't finished that, do that. But I'm not going to give you anything new over the weekend. Okay, I'll wait till Monday to do that. All righty. All right. Okay. That's it. Like I said, I'm going to post this